Hello, guys. I wanted to get on and kind of go over the blood flow of the heart, the function of the heart, and also to go over some of the parts of the heart. So we know Miss Levis can't draw, but here's what I have. Okay, I'm using my kids' easel, so it is what it is. But you can also see my screen here, and I did post these notes for you guys, so please feel free to scroll through them as we go through this, okay? So again, guys, the function of the heart is to pump blood throughout the body, okay? So it's basically brings in deoxygenated blood to the heart, and then the heart pumps that to our lungs, and then our lungs bring back oxygenated blood to the left side of our heart, and then our heart pumps that out through the aorta and the subclavian, which is over here, but I didn't put that on here. But it will pump it out to the rest of the body, and then as it circulates through our body, it is taking up the waste and circulating nutrients and gases that our body needs. So we breathe in oxygen and then we exhale carbon dioxide. So once our blood comes to our heart and goes out our pulmonary arteries to our lungs have these little capillaries which allow for gas exchange. So it exchanged the carbon dioxide that our body produces with oxygen, and then again it comes back to the left side of our heart to where it then gets pumped to the rest of our body. Okay, and if we look back to our anatomical terminology, if you remember, what is the region behind our sternum where our heart sets? And remember, your heart is the size of your fist, so if you take your fist and you kind of set it on your sternum, and it kind of sets more to the left side, this is your pericardial region, if you remember that, okay? And then our lungs sit on either side of our heart, and those are our pleural, okay? Because we don't have one lung, we have two. So remember, I asked you guys to remember that by saying our pleural. So we have our pericardial. And so you also have to remember the membranes that surround that. You have your parietal pericardium, you have your visceral pericardium. And your pericardium, if you remember, your visceral is what surrounds the actual heart itself, and then your parietal is going to be what surrounds the cavity that our heart sets in, okay? So these are the protective coverings down here that you can see. And then the heart structures. So there are 4 hollow chambers. You have 2 atria and 2 ventricles, okay? You have your right and your left atriums up top where the blood flow is collected. And then you have your left and your right ventricles, which is where the blood flow is then pumped to the rest of our body. All right. There's also the septum right here, which separates the left and the right side of our body, because you don't want this deoxygenated blood mixing with oxygenated blood. Okay, so that is the reason for this septum. You'll also notice that I colored this half a little bit thicker, and we'll get to the reason why that has to be thicker than on this side, okay? So if you look at this picture, if you look at this picture right here, you're going to notice, let me just open this slideshow up. If you look at this, you're going to see the aorta, and again, here is your superior vena cava. So superior is above, remember, and inferior is below. So you have a superior vena cava and an inferior vena cava here and here, and I've also drawn them on our hearts, so superior, inferior. All the blood from the upper portion of your body comes from your superior into your right atrium. All of the blood from your bottom half of your body comes in through the inferior vena cava into the right atrium as well. Now, guys, what you do have to remember is this view of the heart is our frontal view. There is also a posterior view, which I did not draw on here. And so you would have things that look different on the back of this. And you also have to remember that this is going to be a cut down the middle of the heart. So if you were to look at a heart, there's a covering that would go over this that we will look at as well, okay? So what happens is the blood comes in from our inferior and superior vena cava, and it collects right here in this atrium, all right? And then we have these valves, which are called your tricuspid valves, okay? And when we were dissect the heart, which we unfortunately don't get to, but if you were to dissect that heart and look at the valve, the reason why it's called a tricuspid is because there's 3 flaps that make up that valve, okay? And if you look at this picture right through here, these little strings are called the choroidae tendineae. And if you've ever heard the saying, man, that really pulls at my heartstrings, that would be what it is talking about. And these are what control this flap, okay? So these are part of the muscular system. And again, if we were to dissect the heart, you would really be able to see these choroidae tendineae. And when people say that they die from a broken heart or that they have died from a broken heart, there is a syndrome for that. What happens is these choroidae tendineae basically no longer work. And so that's how they would die from a broken heart, is because these no longer work, and so it doesn't allow the valves to function anymore. But once our heart has received deoxygenated blood, okay, comes into the atrium, this valve opens. Whenever you hear the lub-dub, lub-dub, lub-dub of an EKG, that is this valve opening and one shutting. Open, shut, open, shut. Because again, you don't want your oxygenated blood mixing with your deoxygenated blood, okay? So it comes in, it goes out your tricuspid valve, and then it goes into the right ventricle. Then you have this valve that opens, and you can see that it leads to your pulmonary arteries. Now, pulmonary means lungs, okay? So this is going from your right ventricle to your pulmonary arteries. Couple things. The way that you can remember arteries is an A, okay? Your arteries carry blood away from your heart, okay? So if you can remember that, it's carrying blood away from your heart. Veins, which starts with the V, carries blood to your heart, okay? So you have 2 fingers, it carries blood to your heart because it makes a V. So a lot of times, the majority of the time, this blood that is carried away from our heart is oxygenated, right? Because you want it to go to the rest of your body. However, in this one situation, because we are carrying deoxygenated blood to our lungs, that is the one time it's carrying deoxygenated blood. Otherwise, you always want it to be carrying oxygenated blood, because then it would go out your aorta, down through your abdominal aorta, which is down here, which again, I didn't draw, but here we'll put it. And then it would go out to the rest of the body, okay? So then once the blood has gone to our lungs, done gas exchange, because it gets rid of the carbon dioxide and goes to oxygen, it then comes back through your left and right pulmonary veins, because it's going back to the heart. Now, once it's in the heart, it's going to go to your left atrium, okay? So if you look at the picture on here, here is your left atrium. The blood comes back from the lungs to here. It goes out in this bicuspid valve, and then it is kept in this left ventricle, and then in which case, it then gets pumped out the aorta to the rest of the body, okay? You can see your brachiocephalic trunk. If you remember, guys, our anatomical terminology, what does brachial mean? What region of the body is that? Your upper arm, right? Your cephalic region, where is that? That's your head. So this artery is the major artery that goes to your arm and your head. You also have a right subclavian that comes out over here as well, but then you have your carotid artery, which comes out on your left side. You have your left subclavian, and these are the ones that are major to your brain. Now, once these have gone out to the rest of the body, then it just keeps going through that gas exchange, sorry. So, what happens is as we have, as the blood comes in, goes out to our lungs to get the oxygen, and then back into our heart, the reason that this muscle through here, well, your heart is a muscle. It's cardiac muscle. And what do we know about the cardiac muscle? Cardiac muscle is involuntary, okay? Meaning that it pumps without itself. And so we don't have to tell our heart to constantly pump our blood. And so the reason for this half of this muscle of our heart being, I'm going to move this, being thicker is because, let's think, this half is only going to our lungs, which is just right on either side, right? This half has to be able to make more pressure and be more forceful to get blood to the rest of our body, that this side of the muscle has to be thicker. It has to be able to support that amount of pressure and that amount of force to get the blood to the rest of our body, okay? So again, every time you hear the lub-dub, that is your tricuspid and your bicuspid valves opening and shutting to allow the blood flow, okay? You don't want this blood here to go back up into your right atrium, okay? So it has to shut. You want this blood comes in, it fills this chamber, then you have it opens and it allows the blood to go into the ventricle. It is then taken out through your pulmonaries to your lungs, and then when it's brought back, it fills this chamber, comes down to here, empties the chamber, okay? Now, that's pretty much, so here's what happens. And I also want to point out, you have blue and red structures on this heart. That is not the actual color of it, okay? And that is not the color of our blood, okay? So we have our blood, which is deoxygenated, coming through here, okay? And as it comes through here, it then goes out our pulmonary arteries to our lungs, okay? So here's our next one. Over here's our lungs, but as it comes back, it is coming in through all pulmonary veins because it's going back to the heart. And then once it collects inside of this region, okay, it then comes down to the left ventricle. And then there's a valve that kind of comes out over here, which again, I tried my best to do this. But then behind this valve, you have blood flow that comes through here and then out the rest of your body. Now, it doesn't cross, guys, into this path. Look at this picture is better, okay, on the PowerPoint. But it doesn't come out this path, all right? So now, you can go through and look at what everything does, and then this image is a little bit better, kind of illustrating what exactly does happen. So here's your right atrium, your right ventricle, and then it goes out the pulmonary valve, out to your heart, and then it comes back through the pulmonary arteries to the left atrium, and then your left, here's this valve, to your left ventricle, and then this valve right here is your aortic valve. It goes out that and around. And again, had we been able to dissect, we would have been able to see these actual structures. Guys, I'm going to stop the video because I only have 30 seconds. I will save this video, upload it, and I'm going to finish the other video. So there'll be 2 videos, okay?